Hi everyone, today we are going to be talking about physics. In this video, you will learn about and observe demos of electrostatics, air pressure, rotational inertia, and mass distribution. And of course, why physics is so fun. In this demo, we are using the fur to transfer electrons that have a negative charge onto the rod. The rod then attracts the meter stick, allowing it to start rotating. The negative charge of the rod makes the near side of the meter stick positive and the far side negative, so the meter stick becomes electrically polarized, basically like a magnet. Charged things attract uncharged things, which is exactly what you're witnessing here. The device in this video is called an electroscope. It shows if something is charged. The electrons transferred from the hair onto the balloon make the metal leaves inside the electroscope spread apart. This means the balloon is charged. The electrons transferred from the hair to the balloon in this demo are used to pick up little pieces of paper in the petri dish. The negative charge of the electrons attracts the neutral charge of the paper. This process is known as polarization. The papers are able to jump because electrostatic force is always stronger than a gravitational force.
Does air have weight? As you can see right now, we are able to lift up the bell jar, which is full of normal atmospheric pressure air. To the right, this is a vacuum pump that is removing air from the inside of the jar. Since we removed air, we are creating a kind of vacuum where the inside pressure is much lower. Now, we cannot lift up the jar because of the outside pressure holding it down. We put a balloon inside this bell jar now so we can see the relationship of pressure and volume in a controlled environment. According to Boyle's law, pressure and volume are inversely proportional, meaning that if pressure decreases, the volume will increase, and vice versa. This is shown in the bell jar because we know that we are removing air from inside, so the pressure is decreasing. Therefore, the balloon's volume has to increase, which we can see is happening as the balloon is growing inside of the jar. We can see the same relationship of Boyle's law as we let air back in, letting the pressure go back up and equalizing back to standard atmospheric pressure. The volume of the balloon decreases.
Ever wonder how figure skaters speed up their spins? It's actually a physics trick using angular velocity. The angular momentum is dependent not only on the angular velocity, but also the distribution of the mass. Demonstrated here on the chair, if the angular momentum isn't changed by an outside force, but the distance of the weights from the center of the mass change, the angular velocity will also have to change since it still equals the same momentum. As she pulls the weights closer to her body, the chair spins faster since all the momentum is conserved.
Which one will roll faster, the disc or the hoop? You can see that they are the same size, but when we roll them down the ramp, the disc rolls faster than the hoop. The clear rings show the mass distributions. Since the mass in the hoop is farther away from the axis of rotation, it has a greater rotational inertia, which means that it takes more for it to start rolling, so the disc beats the hoop. If the mass is centered in one location on the outside of the hoop, even if you give it a push, it will not be able to roll down the ramp.
We hoped you learned something new about physics during this video, and we encourage you to keep learning more. Thanks for watching.